Okay, this is a video about Chapter 17, Probability Models. We're specifically talking about Bernoulli trials. Really, if you want to consider a Bernoulli trial thing, cross, these are the conditions. There's success or failure, in this case, heads or tails. The probability of the success or the failure for each trial is the same. Every time you flip a coin, it's 50% heads. And the trials are independent. Just because you got heads 5 times in a row, it's still going to be 50-50 the next time around. And then we have 2 models when we're dealing with Bernoulli trials. We can have the geometric model, which is about the number of trials until you get the first success. Some of the notation is the same between the two. The binomial model has to do with how many successes you'll get in a given number of trials. I'm going to do an example, and I'll refer to a couple of examples here. If you were in class, you saw them. If not, you can look them up. But the example I do in the next video sort of covers a lot of this. So P is the probability of success. Q is the probability of failure, which is 1 minus P. If there's a 20% likelihood of success, there's an 80% likelihood of failure. In the geometric model, X is the number of trials until the first success. And you'll see this notation. If I want to know what's the likelihood that I'll get a success on the 7th try, that means I got failure on the first 6 tries and success on the 7th. We have an expected value, which is the mean, which is 1 over the probability. If it's a 20% probability, that's 1 in 5. So how many people, for example, and one of these is about blood donors, you expect to test before you got a universal donor. Whether if it's 1 in 5, you'd expect to test 5 people. Standard deviation is a square root of Q over P squared. There's a spam example, spam being junk mail, on page 390, and there's a blood donor example of the geometric model on page 391. If you weren't in class, I suggest you go through those. In the binomial, now we have a certain number of trials, so that's N. Probability of success and failure is still P and Q. In this case, X represents the number of successes in a certain number of trials. NCX, you guys see this on your calculator as NCR. That is, suppose there's 100 blood donors, and I would expect 10 of them to be universal. That means how many different ways could I find 10 in 100? So think of, 100 people lined up. How many different ways might 10 of them be universal? So that's, I have 100 people, and I want to know how many ways would 10 of them be universal. So it's that many ways times the likelihood that 10 of them are universal, and then therefore 90 of them are not. Again, you'll see this example shortly. And then a mean is just the number of trials times the likelihood. And if it's 10% of 80 people, that'd be 8 people. And standard deviation is just the square root of NPQ. And again, the binomial model is applied to the spam example on page 395 and is applied to the blood donor example on page 395. So before you proceed with these models, you should check the assumptions with a condition. Do we have success or failure? Is it or isn't it? Is the probability constant? If it's random, you can check this assumption with a random condition. And is each trial independent? Sometimes it's hard to tell, but as long as you're sampling less than 10% of the population, you can check that assumption. You're going to see an example where when things get kind of tedious, we can use the normal model for the binomial probability. And let's see, binomials are discrete. It's the number of successes in a certain number of trials. A normal model is, a continuous probability. However, if you can have at least 10 successes and at least 10 failures, the binomial model behaves like the normal model. So those would be the conditions you would need to check. And there's an example of that on page 398. I also have some calculator notes here, and I might take some time to show you how to do that. Note these are right here, and we'll see how that goes. So that's the introduction. I'll include this page of notes with on the page of this video on Canvas. Next video is an example.